Welcome to Laplink Connections. Today I'm talking with Gary Martz, who's the Director of Industrial IoT at the Intel Corporation. And for me, he's more Mr. IoT at Intel. So, hi Gary, how are you?
Good morning. I'm doing fantastic.
And the other thing I would say in this discussion is, usually I say, well, Gary's only expressing his viewpoints and not that of Intel. But I think in this case, it's more usually Intel follows Gary's opinion, so it's probably pretty much the same. So, Gary, let's talk about the digital economy. In recent years, and probably because of COVID, the discussion about the digital economy has really cooled down quite a bit, at least in what we hear. Yes, we're talking about better access to the internet. Politicians talk about more broadband and bandwidth, but that's just part of the story. Have we made so much progress that we don't need to talk about it anymore?
Absolutely not. And I think in my role in standards, we're always looking, 5 to 10 years in the future and driving broad industry alignment. And everybody, when you kick off a new effort, there's a lot of excitement and a lot of discussion and a lot of people trying to figure out and discuss and sharing their opinions about what's going to happen. Then people kind of get tired of listening to that, and people get tired of talking about that, and they move on to the next shiny object. In reality, though, it will come back around. When those hypothetical discussions start to appear as real and tangible benefits, then the discussion is going to get picked up. And when you look at the innovator's dilemma and the trough of disillusionment, I think we're in that period of time where people are just disillusioned a little bit, or it's not top of mind because it's still out in the future before it's complete. But no, I mean, we're seeing things like cryptocurrency, starting to hit the mainstream, more IoT devices, more data. We're still figuring this out and the implications to society. So no, we're still very much at the beginning.
So when people talk about the Internet of Things, they often talk about the smart light bulb or your Alexa, the talking refrigerator, the smart car. But isn't IoT going far beyond the immediate consumer market as we discuss it?
Oh, absolutely. And there's still so much to do in the consumer market. In my house, my wife has to suffer because I bring home a lot of toys. And just one example, in our family room, I have 3 or 4 different smart light bulb products. And, I'll spend an afternoon and I'll get them all set up and I'll connect them to our smart speaker. And, it's really easy. Hey, turn on the living room, turn off the living room. I can set routines where they automatically go off at a certain time of night. Or when we're on vacation, they cycle on and off. So people don't necessarily know that we're not home. It all works great. But then 6 months down the road, there's a software update, there's a firmware update, and something doesn't work anymore. And then it's a tremendous effort to go back in and try and remember how I set everything up. That's in the consumer space. So we still have a lot of ways to go, but now we're talking about, factories and smart devices in factories. And we look at it, I look at it, and the group I support at Intel looks at it as 3 phases, high level. 1, we got to connect the unconnected. All these devices, all these things, all these sensors, we need to get them connected to a network. Obviously, that has a lot of implications with security and privacy and such that we have to consider. It's a big problem. Then once the devices are connected, it's like making these things smarter. So connect the unconnected, now make the connected devices smarter. And this gets into big implications around data. Data formats, data consistency, data interoperability, data privacy, geopolitical laws around data and where it can go and how it can be used. Once we solve those problems, then we move into autonomous systems and autonomous functions where machines and devices can start thinking for themselves, but based on algorithms that we create. So IoT, consumer IoT is still in the infancy. We're moving to industrial IoT cases. And then the big, fun, sexy one is also autonomous cars. And how do we move there? And what does that mean?
Yeah.
So we're very much in the beginning.
So you do mention industrial side of IoT. So if we control or measure certain data, doesn't that also mean that we need to capture, manipulate, and analyze the data? Otherwise, it doesn't make any sense. And if I'm right, then, for example, an engine of a Boeing 737 MAX, that has been in the news so much, has about 5,000 sensors, creating about 10 gigabyte per second per engine. I mean, that is really big data. Mm-hmm. Does that mean that the world of IoT also influenced the immense growth of big data, storage, computers that hold intelligent edge around?
Oh, absolutely. And I mean, I think you may be understating the data generated from those engines. I know there's one data point that I just looked at, that a autonomous car will generate 40 terabytes of data for every 8 hours it's driven. That's huge, and the implications around that. And then you look at real examples that we're seeing in the news right now about ransomware attacks, where hackers will grab that data, encrypt it, lock it, and not only that, even if you get access to your data, they potentially have copies of it and can do a lot of different things and make it public and create a lot of bad problems. So yeah, I mean, I think this whole process, the more we learn, the more we understand what we don't know. And, some of these implications about the data that we're generating, it goes well beyond having access and be able to compute in a timely fashion to do the functions that we need that are very specific and coordinated with other machines and devices and cars. It also goes to the government, regulatory around that data and how it's protected and how it's used and where it can be stored. Because like I said, I mean, we're learning real time that right now it doesn't take a lot for someone to get access to that data that shouldn't have in some cases.
Yeah. I think it's hard to believe how much data, if we think of one engine or one autonomous car, and we have thousands or millions of that. And of course, the data is only there not to drive the car, but the data is there to analyze what it does and to make it better. Plus, probably also how to operate it. It needs a lot of data.
Well, the for a business, the CapEx and the OpEx implications of having access to this data are huge. I fly a Boeing 747, and like you said, I have sensors all over my engine. Now I can start doing predictive maintenance. I can start analyzing failure modes and failure mechanisms, and I can see it coming. So now when my plane is in Chicago at one of the main hangars, where I have my technicians and I have my parts and I have my tools, I can fix it versus having it at some remote airport where I have to fly in the technician, fly in the tools, and fly in the parts, where that capital intensive equipment is now sitting on the ground for a couple of weeks. But this also, it's not just the data, it's also access to the data. So I've mentioned regulatory and government and where you can store it and how you can move it. But the communications frameworks around this data is also huge. I mean, when you're driving a car, you're flying a plane, you have to have instantaneous access to some of that data so that your car can make immediate split-second decisions. You're also going to want some of that data in the cloud. And you're going to want to be able to have a broad view of the environment that vehicle may be, driving, so you can, start looking ahead and predetermining some decisions. The trick is, how do you filter that data and the cost of transporting that data over a network to get it to where it needs to be? You have to be really efficient.
Yeah, I mean, self-driving cars is certainly, a really, a good point of discussion. It seems that we are certainly not there looking at the true 5G status, not just what we hear in marketing, connect to your 5G network. That's not 5G in its totality, and the interoperability of data that you serve. I mean, what we see today with all the autonomous cars, I think, is they see what the car can see. Yep. But they can't see what comes around the corner behind the building, because that would mean that data is sent to the other car so that it knows there's a car coming from the side. So when do you see real autonomous cars? Is it a year? Is it 5 years? Is it 10 years?
I don't know if I'll be able to predict that accurately, but I can tell you that it was probably 5 or 6 years ago. I was invited to a conversation in Washington, D.C. with the U.S. Department of Transportation and some of their executives and experts, some members from some of the leading universities and some of the leading technology and communication companies in the U.S. And we were having this very conversation about when is autonomous driving really going to be here. And the one thing they were missing in the room was an economist to really be able to talk about and identify and prioritize the benefits to society, the benefits to cities, the benefits to big business on how to fund the infrastructure that has to put in place to make this happen. I mean, if you look at the cost of traffic jams in cities, not only to personal commute time, but also for freight. Mm-hmm. If you can fix that problem, which we will be able to do with autonomous driving, if you look at the system, or if you look at a city highway network and transportation network as a system, everybody's trying to drive 65, 70 miles an hour, and we get these huge bottlenecks that just compound. If everybody just slows down to, say, 30 or 35 miles an hour, traffic will flow smoothly. Humans making that decision, we don't have that view, and often we don't have that patience. But once you have a network that a city runs, that autonomous cars come into the system, and now they're communicating back and forth with the infrastructure and with those other cars, to me, that's the real benefit, the economic benefit of autonomous driving. So it's not just, me getting to the store or being able to watch YouTube videos on my phone and not have to pay attention to the road. The economic benefit is how you make that city and that transportation network more efficient. And maybe you get to the point where you're not adding a 5th or 6th lane to your highway. Maybe you're actually be able to get to the point where you're more efficient and you can actually reduce the amount of pavement in your city, because now the city and the infrastructure can help manage that system of vehicles.
Yeah. No, we can see real world. Go ahead.
Well, to answer your question, when is this real? How long does it take? I think we're still talking a decade. We're starting to see examples of, autonomous taxis for companies like Zoox, who's now owned by Amazon, and who the CEO was one of my friends and colleagues and mentors at Intel. And, that vision of when that becomes real, that's, a decade out.
Yeah. Yeah, I think I remember always that my old boss, Bill Gates, said, we overestimate what we can do in 2 years and we underestimate what we can do in 10 years. Mm-hmm. So, and of course, technology is ongoing. In 10 years, we might see a totally new system. But I just wanted to interject one of the real-time problems that we have today. We just got the information that, our cables that we need sometimes for our consumers to move data between computers, the shipping costs from Asia has tripled. Yeah, mm-hmm. They have. There's total congestion. We have the chip shortage that has been widely discussed, not necessarily only for computer chips, but in chips everywhere. And so to have a totally different view on where the ships are, where they need to go, perhaps to different harbors, that is today not in place. And so to have a very different way of communication of all these pieces certainly can be a big economic impact. But let me go back to the base question of IoT. I think in technology advancement, we always see, and that was at least in the past, that first comes the proprietary solution. Somebody has an idea, puts the solution first, before we see any kind of standardization.
Yep.
How is the industry today and all the important players dealing with that? Which is part of your job.
Yeah, I mean, first and foremost, the proprietary solutions, it's common, and it's actually a natural progression. These are developed to meet unmet needs for customers. And they're very good and they work well. And, the companies that develop them need to see a return on that investment. So they protect that IP. And then you start to see more technologies develop to satisfy similar needs. And so now you have an ecosystem where you have a bunch of competitive protocols that's actually inefficient for the market. And, my job at Intel is pretty simple. For industrial, it's let's remove inefficiencies from the market. Let's let the market rapidly proliferate. Let's let sockets proliferate. And then my counterparts on the sales side, then they go compete for the sockets. So we're looking at inefficiencies, and as markets development and develop and as proprietary solutions evolve, that creates a natural inefficiency. Ultimately, companies and businesses will start looking at their investments that they're making in that technology and what it costs them to maintain that proprietary technology. And then they'll start to look at their overall business and where the value is and where they would like that investment to go. And they start to collaborate and they start to talk to other people and they say, hey, we're all doing the same thing. This isn't real business value. Can we collaborate on a broad scale and share R&D investments across the industry for these problems that should be solved together? And that's where this broad scale collaboration, that takes the form of industry standards and open source projects. Because of course we have to do it in a very open way that meets and satisfies any antitrust concerns. It also introduces a massive amount of business model disruption. There's entire industries that are built around proprietary solutions. And now you need to co-opt those companies into developing standardized solutions. And so, I have this conversation on a regular basis about the standards process is long. It's somewhat messy. And to your point, it takes longer. We overestimate what we can do in the near term and we underestimate what we can do in the long term. But I just met with a company yesterday on this very topic, and they made a point that in general, you'll look back after a long period of sustained effort to develop standards for an entire ecosystem, and you look at the result, and you're very, very happy that you took the time to do it right.
Yeah, I think that's good summary of that, because at the end of the day, if we don't collaborate, we might have a short-term gain as a company, but not a gain as a society. So, yes. It has to be, much more interoperable in that sense. Well, last perhaps question and a little bit off topic, but given your job, you have traveled for business worldwide, and you probably were more on the road than at home. So after COVID, do you see yourself continuing with your home office and video conference, or will you go back to pre-COVID behavior?
Yes. I've actually enjoyed working from a home office. I've been a lot more efficient and productive than I ever would have predicted. I also, the nature of what I do with standards and open source, I describe, myself and my colleagues as technology diplomats. I'm never the smartest person in the room when it comes to the technology and the architectures and how you swizzle the bits in the right way. And there's only, my skill set is forming the connections with the colleagues from other companies and the colleagues from competitors. I mean, I'd say some of my best friends in the industry are from companies that are some of Intel's biggest competitors. But we enjoy solving these problems, and those connections are important. We've been able to maintain them over video calls because we built strong connections prior to COVID. It's fun. Like you, I mean, how long have I known you? It's fun to talk to you on a video call. I would much rather, enjoy a meal with you at Daniel's Broiler or, drink a bottle of wine in the San Juan Islands or something. So yes, we've been able to maintain our work and be efficient, but when COVID's over, I can't wait to get back and sitting down for lunch or a dinner with some of my colleagues across the industry face to face to strengthen those connections, and it makes our work easier to get done when we have to solve the hard problems.
Yeah, I think the human factor, you're absolutely right. The human factor is very, very important, in all kinds of relationships, whether it's business or in any kind of organizations or politics or whatever. It's the human aspect of it. And no matter, technology is always helping us to do the right job. And,
it also works in the reverse too. I think there's a lot of spouses of those of us that travel a lot that wouldn't mind seeing us, go on a business trip every now and again so they can have the house to themselves.
Yeah, but they also don't want us to go, 8 months out of the year. So
exactly.
And I must admit that there are certainly some places, where I don't want to go for, one meeting. Where you have to travel for 20 hours just to be in a meeting and then, get back on the plane. We try always to be efficient, but, sometimes it is easier to just have a conversation, with Teams or Zoom or, whatever the technology is you use, and, exchange the information you need to exchange, get to the bottom of it and do that. But for relationship building, personal contact is important.
Absolutely.
Well, thank you very much, Gary. It was a pleasure seeing you. I'm looking forward very much to see you in person and have that glass of wine. And we will do that very soon, I hope, because everything is pointing to that direction. Thank you very much for your time today. And, all the best for you in the immediate future.
Yeah. Thank you, Thomas. It's always a pleasure. Truly.
Okay. Take care. Bye.